Okay, here's warm-up number 9. We're going to factor this completely, so I'm breaking it apart into a multiplication problem. And I'm looking for a common factor, but 2 doesn't go into 5 or 12. There's nothing that goes into all three of those terms. Okay, so I'm going to factor this with a diamond problem. Since there's that coefficient in front of the x squared, I'm going to take that and multiply it by the constant at the end term. All right, so I'm going to change my trinomial so that 2 I'm just going to combine with a negative 12. So it's going to disappear from the front. And then 2 times negative 12 is negative 24. Okay? Now I can factor this with a diamond problem. I'm putting the negative 5 on top and the negative 24 on bottom. And I'm looking for two numbers that add to negative 5 and the same two numbers multiply to negative 24. So I'm going to kind of start thinking about some different ways to multiply to get 24. Okay, now one of these is going to have to be negative, but okay, I'll just write them both. So I'm looking for a pair that's going to add to negative 5. So let's see, 2 and negative 12, or negative 2 and 12. Those don't work either. Let's keep going. 3 and negative 8. Hang on, I got a winner, right? 3 and negative 8. There's other pairs that I could multiply, but only one of them is going to add to negative 5. That's my winning combo, so I'll stop there. Okay, so I've got x plus 3 times x minus 8. But I changed the trinomial, so now I have to change my answer. So I'm going to undo what I did at the beginning. In the beginning, I multiplied by 2. Now I'm going to divide just the number parts by 2. So I'm going to write them as fractions, like so. Okay? And I'm going to reduce and simplify them as much as I can. So 8 over 2 is 4. So this would be x minus 4. Now I can't reduce 3/2 any further. So I'm going to take the denominator and pull it out in front of the x. And then the 3 falls to the ground. And there is my solution. You can try out multiplying it back together. Should get you back to this, okay, if you foiled it. All right, next up, we're going to write a function for a vertical stretch by a factor of 4. Okay, so I'm going to call my new function g of x, just so it has a different name than f of x, okay? But what I'm going to do to this, I'm going to multiply, so just looking ahead, if you have a vertical change, it's going to be something multiplied on the outside of the parentheses if it's a quadratic equation or the outside of the absolute value, okay? So I'm going to have a coefficient in this position. So I'm going to have some sort of a coefficient that I'm going to multiply my entire equation by, my entire function by, okay? So I need to put something in that position, okay? And that something here is going to be a 4, because a vertical stretch, if you think, let's think about I'll use the absolute value to start with. If you had this and you did a vertical stretch, that means those points, the vertex stays where it is. Those are going to stretch straight up, though, which is going to make this look narrower, right? And so a vertical stretch is gonna make things look narrower, and that's gonna happen when we have a number more than 1. And so this is gonna be 4 here, okay? So I'm gonna now use substitution. I'm gonna substitute all of this in where f of x is, because that's what f of x equals, right? But use parentheses when you do that. So I've got it like that, okay? Because a lot of times people will just put a 4 here, and they'll forget that you need to distribute a 4 down there. Also, some people distribute inside the parentheses, but you can't do that since the parentheses is squared. If I didn't have that exponent, yeah, I could multiply inside the x plus 3. But all I can do with this is that, but that should be a negative 4. A lot of people miss that and write a negative 1. Now you could multiply out x plus 3 times x plus 3 and then multiply the 4 into it, but for me this is fine in this format, because for parabolas it's actually nice to have it in this format, vertex form, if we're going to graph it, okay, which we are going to be on this problem. Okay, write a function for a reflection over the x-axis. So when we're going over the x-axis, we're going to change, I think about it as, oh, well, you would change the y-coordinate if you were reflecting just a single point over the x-axis. And f of x is kind of like y, right? So we're taking the opposite of the whole function. So again, I'm going to use parentheses here when I substitute in all of this for f of x. Okay? And that's going to remind me to distribute. So I can distribute a negative here and here. I can't go inside those inner parentheses though because they're squared. Okay, and if you did want to simplify either of these further, don't just square both terms. You'd have to think x plus 3 times x plus 3. You'd have to FOIL it, right? Same thing here. Okay. All right. Next up, we've got a quadratic function. So this is going to be a parabola when we factor it. Let's find the vertex first. So I'm going to take the contents of the parentheses and set them equal to 0. And then I'll solve this for x. So just subtract 1 from both sides. That's going to be the x coordinate. And then the y-coordinate is whatever is added or subtracted to the end. So my vertex is going to be the point -1, -3. Okay? So let's start graphing as we go. I'm going to put that into my graph down here. -1, -3. There we go. Okay? Another thing that's useful to realize is that which way your parabola is going to open. So this one, since that 2 is positive, that means this is going to open upwards. If I had a -2 or a -7 or any negative number there, just a negative symbol itself, then it's going to open downwards. But this one opens upwards. Okay? Let's describe the transformations then from the parent graph. So let's the most difficult one to deal with is this. Okay? So let's deal with that first. So, first off, it's a number more than 1, so this is going to make my graph look narrow. Now, that's not a technical term for a transformation, but just visually, that's what's going to happen. It's going to look narrower than the parent graph. Okay? All right. So also, since we've got a number that's on the outside of the parentheses, then it's going to be a vertical change. Okay? The x-axis is the horizontal axis, and that number is not directly attached to the x, so that means it's going to be a vertical change. So now I'm thinking vertical change for a narrower parabola. Well, let's go back to this little sketch I made. Vertical change, to make it narrower, if these points can only move up or down, that's a vertical change, you'd have to move this up. If you moved it down, the V would get flattened, right? And it would look wider, but this looks narrower when you're stretching it up. So it's going to be a vertical stretch. So I'm using vertical and narrow together to figure out that that must be a vertical stretch. Okay? And then this, if you just think about where the vertex is, we've moved the vertex left 1 and then down 3. So this part's going to be a left 1, and this is going to be a translation down 3. So yeah, you can write out translation, but if you just say left 1, down 3, I would take that. Okay? And the factor of the stretch is 2 here. But I didn't write that down. That's okay. All right, so let's graph this now. So you'd want to know what the parent graph looks like. So I'm going to plot what I call my ghost points. I'm going to pretend that there's no vertical stretch, okay? I'm going to draw my parent graph except coming from this vertex. So I would go up 1 to the right 1. I'm doing this in pencil kind of lightly, all right? And then from the vertex, I would go up 4 to the right 2 and up 4 to the left 2. That's because, you know, if you square 2, it would be 4, right? So the next points, if I graph them, I'd go up 9 to the right 3 and up 9 to the left 3 if I'm just doing integers, okay? So with no vertical stretch, that's what it would look like. But before we draw anything in, let's actually do the vertical stretch. So vertical stretch means I'm going to take these points and move them all up. So looking at these first 2 points, I can see those are both 1 unit above the vertex. So I'm going to double that since my factor is 2, okay? So those 2 points then would be 2 units above the vertex now, okay? And then looking at the next set of points, those are 4 units above the floor, above the vertex, right? So I want to double that. So I want them 8 units above. So 4, and I want to go another 4. And that would put me here and here. And now with those red dots, I can draw in my parabola, and I've got a pretty good idea what's going to happen next of the shape of the parabola. Pretty good graph there. So you don't need to graph the ghost points, but I like to do that to describe what's happening. But you do need to plot those critical points. It says include 3 critical, well, I did 5, but there we go. Okay. All right. That's it. See you next time.